Hi, this is BRR. In this video session, we'll talk about hash table collection C sharp. So far we have seen so many non-generic collections like the array list and sorted list and stack and queue. And this hash table also part of non-generic collection. It's not part of generic collection. So we'll look into this more on this hash table. So generally, hash table class. This class is used when you need access elements by using key, and you can identify a useful key value. So that context will going to use this hash table. So each item in the hash table has a key value page. That is what is the syntax of hash table, and the key used to access the items in the collection. So basically, this hash table have similar kind of structure. Dictionary, like hash table and dictionary are a collection of data structures to holds data as a key value pair. But dictionary is purely generic collection, and when it comes to hash table, it's a non-generic collection. What we're talking about non-generic collection context. So when it comes to hash table, as I told you, it's a non-generic collection. It has a weak, type of data structure because we can store any kind of object or any kind of value in the hash table, and that is what the reason it is a very weak type of data structure. When it comes to dictionary, it's a strong type data structure where we can store the strong type data. That is what the difference. So what are all the built-in methods we have in this hash table to access the values based on the key value, and what are all the methods we have. So if you look at the properties of this collection, we have several properties: count and is read only, and item and keys, values, and remove, add. Of course, sorry. So these are the properties basically. So count, is read only, item, keys, values. These are the property things available in the hash table. So generally, this count refers gets the count of item in the hash table. And coming to the read only, it indicates, or it will return a boolean value whether the hash table is read only or not. So it returns boolean value whether hash table is read only or not. And coming to the next item, so the name itself says that it sets or gets the value associated with the specified key. Gets or sets the item value associated with the specified key. So whatever the key you are specifying, so with associated with that key, the value will get retrieved or assigned. Okay. And coming to the keys attribute property, this keys property used to get the collection of the keys in the hash table. Gets an collection of keys in the hash table. And coming to the last one, values. This property used to get the collection of values in the table. Gets an collection of values in the table. This is the opposite of keys. So these are the properties we have in hash table. So based on these properties, you can get the required relevant definition from the hash table. And coming to the methods, we have several methods along with add and remove. So first method we'll talk add, and next one is remove and clear, and contains, and contain key also there, contain key, or contains key and contains value. So, and last one is get hash. So these are the built-in methods comes up with the hash table. So based on the requirements, so we select the relevant method and use it in the program to get the values. This add used basically for adding items into the table, hash table. So when you use the add, you have to specify the key value along with the value, so that it will store that particular item in the respective key. So I'm coming to the removes the item with the specified key from the hash table. So inserts an item with the key and value into the hash table, and coming to the remove, removes the item with the specified key from the hash table. And coming to the clear, as we discussed in the earlier generic collections, it removes all items in the hash table. It's nothing but reinstallation once your program execution completes. And coming to the contains, checks the whether the hash table contains a specific key. Okay, this is just validating before you use remove or contains key or values kind of method. So it returns the boolean value if specified keys exist on the hash table, and contains key similar to contain method only, but it checks whether the hash table contains specified key. So it checks the specified key contains in the hash table. Check the specified key exists in the hash table. And similarly, this contains value checks the specified value exists in the hash table. And coming to the last one, get hash. This is used for returning the hash code for the specified key. Returns the hash code for the specified key. So these are all about existing methods and properties in the hash table. So add inserts no item with the combination of key value, and remove used for removing an item based on the key, and clears, it removes all the items in the hash table, and contains checks whether the hash table contains specified key item or not, and contains key specific to key validation, and contains value specific to the specified value, and get hash used for return the hash code of specified key. And we'll see some example like how we are going to use hash table. Okay, so anyway, again, this hash table also uses this namespace system.collection. So you have to import that system.collections namespace before you use this hash table. So hash table of my hash of hash table, and I'm writing insertion add of, so I have to specify the key value first, and then you specify the value here. Similarly, my hash dot add of 2, 2, and my hash dot add of 3, 3. So this way you can store values, not only the string values you store, so numeric integer values as well. Also you store null value as well if you want to store. So this is all about the inserting of elements using hash table. So number of elements the hash table. Come on. So if you want to print the hash table values, so you have to use it, the while or do while or for loop. So with that you use it, and that is anyway similar of like how earlier the collections we have been using loop. So that way you have to use it. So now if you see the the count of this thing, if you run it, and you can see the count of hash table items can be, would be displayed on the console output. If you look at here, the count has been displayed as 5. So I've been added 5 items here, hence it is showing uh, 5 elements count as it is. Okay, this is how we are going to use hash table combination of with the key and different values. So we are going to use it. Okay, and one more thing is hash table can also include all the elements of dictionary, as I told you in the introduction part. So example, like if you want to add it, a kind of thing. If you look at if you look at the dictionary syntax, how it is happening. Generally, dictionary syntax, how we are going to declare this syntax for this thing is, dictionary dictionary, and here you have to specify the type, like let us say like integer string, and name is some dict, and a new dictionary of int comma string. So in this way also you can store the values, key value pair dict dot add of 1 comma 1. So because it is an integer and it is a string, because it's strong type data structure, I'm specifying it here, but here there is no guarantee and ensure that it is always having integer value, or here it is always having a string value, because this is the number I have been given, this is null value I have been given. So we are not sure about the data structure we are going to give in hash table. But when it comes to dictionary, I'm talking about dictionary collection. So this is strongly dictionary collection. It is strong type of data structure, because we are specifying the data type very clearly that index should be the key value. Key should be an integer type and value should be a string type kind of thing. We are doing it. So if you're trying to add different key data type key value, then it throws you exception. Look at here, dict dot add of till this. Okay, dict dot add of in third position I'm going to store null value. It won't accept it, because in the same way add of in the fourth position I'm going to add integer value. You don't accept this. So because this when I convert from integer to string, don't accept it. So that is what the reason. This is going to give an exception while you compile the the program. So this you have to ensure that it should be a strong type. So based on the declaration only you have to give it. So we run the program and we'll see this is having 3 elements. Okay. I think so null also access, because it's a kind of string. So no worries about specifying null value. But when you specify other than string value, so like null also part of string data type, okay, accept this null value, hence it is not throwing any error. But when you specify other than string type, definitely it throws the exception. This is how the dictionary collection is going to add the values and store the values. Other than the data type, if you give it, so throw exception. If you try to add a key that already exists in the hash table, also it throws you exception. In this, the dictionary part, suppose I already added 1, 2, 3 index. If I specify again 3, and try to add it. So what it will do, you run this program, and when you go to this and run here, it throws exception because already this index has been given here, hence it is throwing an exception. So you should not use already given index. But when it comes to hash table, how it is going to be, I will see already in the 5th index. So already null value have been given. If I give again another value in the same key, so how it is responding again is also throwing the exception. So this is the behavior of giving a duplicate key value, because hash table or dictionary will not allow duplicate key values here. Hash table is non-generic collection, as I told you, so it can contain key and value of any data type. So value must be cast to an appropriate data type, otherwise it will give you the comparison error, because I'm not sure about this value. Sometimes I may give string, sometimes I may give integer, sometimes I may give another data type. So we have to typecast the value. That's why I'm saying it's a weak type data structure kind of thing. So hash table stores key value base of any data type, whether the key must be unique. That is what here exception is coming. So this key value must be unique in the hash table as well as in the dictionary across all values. And hash table key cannot be null, whereas the value can be a null. So the key value definitely we have to give other than null value, but value we can specify null. So this is what the other point we have to make sure. And also hash table retrieves an item by comparing the hash code of key. So it is slower in performance than dictionary collection, because this is storing all values based on the hash code. So when you retrieve a value from the hash table, it takes some time compared to dictionary. So I will write one more print statement to print hash code, like how it is going to give this hash code of specified key value. So get hash code of 1 or 2 something. So when you run this program, you will see the hash code is this one. So as I already told you, this hash table get hash returns the hash code for the specified key. But here it has been written the hash code as something like 371211646. This is what the hash key of hash table. So this always, I think, it returns table specific value. And I will look at if I say something throws exception. No load of method code takes argument. Okay, I think it always gives the hash code for the entire table, it seems. So hash code of default hash function it is giving, that's fine. So this is how the hash table is working in C#, and hope you understand like how we are going to declare hash table and what are the default methods and properties we have in hash table, and their purpose and the relevant definition against each and every method. Hope you understand the hash table implementation in the C#, and thanks for listening to this video. Please subscribe this YouTube channel for more videos on C#.